Hello. Algebra students, Mr. Lawrence here, and we are going to graph the quadratics. We worked the past day or so on solving quadratics. We're going to be actually graphing them now. Of course, we're going to need our quadratic formula. Time to sing along. Sean, are you ready? X equals negative of b plus or minus the square root of b squared minus 4ac all over 2a. So I've got my quadratic here. Now, if you're really good at factoring, this one would be able to solve by factoring and get the x-intercepts, but we'll go ahead and use the quadratic formula on this. So I'm going to do a, b, c. Easy as 1, 0, negative 4. B is not negative 4 because remember it's ax squared plus bx plus c. That's really the standard form of a quadratic equation, okay? That might be the first time I've shown you. I can't remember if I did that in class or not. It's not actually, I can't remember. We haven't had class yet. Ha ha! Anyway, so I'm going to go x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. And when I simplify, I get 0 plus or minus square root. The discriminant here is going to end up being 16. Okay? I'll leave it to you to figure that out if you disagree with it. And it's all over 2. So I'm going to get x. The two x-intercepts are going to be plus or minus 4 over 2, which will yield 0.20 and the point negative 20. So the x-intercepts are there. Now, remember, parabolas are U-shaped. Quadratics produce the parabola. There's a highest or a lowest point called the vertex. Okay, you've heard me use this term a lot. We talked about the vertex with an absolute value function, something like this, right? And the first thing we did was find the vertex. Now, you can find the vertex first. I like to find the x-intercepts first, to know how many they're going to be. But to find the vertex, we've got two choices, okay? One is in our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If I only use the this part of the quadratic formula, this part right here, remember I had it in a different color in another video? That will tell me the x-coordinate of the vertex every single time. Yeah, so the vertex is going to be some point where I do negative of b over 2a. And now I don't know what the y-coordinate is going to be. I'll have to calculate it, okay? So let me try that. I know that b is 0 and a was 1, I believe. So I have 0 divided by 2, which is 0. And by the way, you see why it's not okay to not know this anymore? We're starting to get so advanced that you have to know 0 over 2 is 0 without even thinking about it, because it'll slow down your understanding of the problems. So you need to come in for help, and you need to practice it, or you need to learn it on your own. Okay, now that I have the x-coordinate of the vertex, I'm going back to my original equation, and if I want, I can make a table. But what I'm going to do in my table is I'm going to plug the x-coordinate of the vertex in, and I'll get this. And so then y will equal negative 4. So 0, negative 4 is my actual vertex. All right, so I can go to the graph and label 0, negative 4. Now, drawing a parabola on this is a pain in the butt, okay? I can't do it very well in class. I can do it so much better for you. So I'm going to draw it using the airliner, even though it's difficult. And but then I'm going to show you on that graphing site I found. In fact, I'm actually going to cheat. I'm going to clone, and where's the flip left? Oops. Because what should happen is your parabola should look like a U, not a V. This looks more like a V. And it should also be perfectly symmetrical, okay, with the vertex being the point of symmetry, or the axis of symmetry. Like this line right here, x equals 0, that is called the axis of symmetry. And the reason is that no matter where I'm at on here, it should be the same distance from the parabola one direction or the other. So if I put myself at the origin, well, I'm 2 units away on the right and I'm 2 units away on the left. If I put myself here, it should be the same distance both sides. Now it's hard to see because, like I said, it's difficult to draw the parabola using the airliner. But let me go to the graphing site here, and let me type in the equation. Y equals x squared minus 4. Okay, and I think I'm going to zoom in on that because we don't need to see all that. There we go. And you look here, there's my vertex at 0, 4. One of my zeros was at 2, 0. The other 0 was at negative 2, 0. And I think you can tell, let's say I'm down here at negative 2. I think I'll be able to write on here. Let's see. Yeah. Okay, so I'm at negative 3, excuse me. Look, I'm 1 full unit away from the parabola to the right, and I'm 1 full unit away from the parabola on the left. It doesn't matter which point I pick. I could pick y equals 2 right here, and I go 1, 2, just shy of 2.5 units right there. And if I go here, I go 1, 2, and look, just shy of 2.5. Again, so that's the symmetry. So the vertex, well, the zeros for this were at, oops, I'm wrong. We're at 2, 0, and at negative 2, 0. And remember, the zeros are just the x-intercepts. The vertex was the point 0, negative 4. And the axis of symmetry was x equals 0. By the way, it's not a coincidence that these two are the same. The axis of symmetry for these will always be x equals. It'll be a vertical line. And the number it'll equal will be the same as the x-coordinate of the vertex. All right, so let's let me get rid of these. Okay, I'll get rid of that equation, and let's go try another one. So this time we have x squared minus 2x minus 8. And I like A, B, C. Easy as 1, negative 2, negative 10. And then we'll go x equals negative of b plus or minus the square root b squared minus 4ac all over 2a. And so when we do that, the negative of b is going to be 2 plus or minus negative 2 squared minus 4ac, and we're all over 2a. Now, will a always be 1? No, of course not. We're just doing some simple ones to get our practice down. So remember, I'm finding the x-intercepts here. So I'm going to have 2 plus or minus. Now, I really should figure out that discriminant. Maybe I'll do that off to the side here. And it looks like I'm going to get 4 plus a 40. So it's going to be 44, my discriminant. There's going to be 2 solutions, but they're not going to be whole numbers. They're going to be irrational, as a matter of fact. And that's going to be over 2. Okay, and I can simplify this rad. Yeah, I'll go ahead and do that. 2 plus, let's see, rad 11, or rad 44 is rad 4 times rad 11, and there's a perfect square right there. So it'll be 2 rad 11 over 2, and then I can simplify this whole fraction. This 2 goes into both that 2 and that 2. So x is going to equal 1 plus or minus the square root of 11. And that's where you can go to your calculator. I don't seem to happen to have mine handy. Let me make sure I'm in a different mode here. Let's see. Google. So what do I got here? I got 1 plus the square root of 11. And it looks like it's about 2 and 12 hundredths. I'm not sure where it went. Oh no, it's not. Alright, so let's put that back in. Okay, it looks like it's about 4 and 32 hundredths, approximately. 4 and 32 hundredths. So one of the zeros will be at 4 and 32 hundredths. And then the other zero I have to figure out, and I'll go back to that calculator there, and I can just change that to a minus. And then, for some reason it's not go, there it is, negative 2 and 32 hundredths. Negative 2 and 32 hundredths. Okay, so negative 2 and 32 hundredths. So this is going to be a little more difficult to graph, but I can still do it. This would be negative 3, negative 2.5, so maybe right about there. It might be a really good idea to label that. Make it clear to the reader what point you mean, because there's an extra. Now, I mentioned in the first problem that there was another way to find the vertex. I'm not going to find it here, but I will go back to that first problem after I do this one. And, oops, that's incorrect, isn't it? 4 and 32 hundredths. Sorry about that. I fixed that before Sean decided to tell me about it. All right, 4 and 32 hundredths. Okay, and so now we need to find the vertex, and that's where I'm going to use this first part of the quadratic formula right here. So let's see, I've got x equals the negative of b over 2a, and the negative of b is going to be 2, and a was 1, and so it looks like that x equals 1 is going to be my line of symmetry, axis of symmetry that I've mentioned. And so I'm going to go ahead and show that as a broken line. It's not really a part of this graph, but I really want to get this idea of symmetry across to you because it makes graphing these so much simpler. You can almost cheat in a sense by not doing every last little step if you understand what you're doing. Okay, well, it doesn't look broken when I make it that small. Okay, so that's a broken, oops. Well, it's not going to let me move it. I'll say that's close enough. All right, so now that I have the axis of symmetry at 1, which it looks like it's about right because I'm like 1, 2, 3, and 32 hundredths, or is it 23 hundredths? 32 hundredths, yeah. So I'm 3 and 32 hundredths away from the point there, and here I'm 1, 2, 3, and 32 hundredths away there. So I know I've got the right point. Okay, so now to find the y-coordinate of the vertex, I'm going to plug in 1 in for x. So y is going to equal 1 squared minus 2 times 1 minus 10. And so that'll get me 1 minus 2 minus 10, which I believe is going to be negative 11. Yeah, I think negative 11. So it's going to be down here. Probably right about there. So my parabola is going to, and again, this is really tough to do with the airliner. Oh my gosh, that looks a nice smooth U. All right, so it's going to look something like that without the extra little growth there. Just something I haven't mastered here. Okay, and then on the other side, it should do the same thing. But again, it should look like a smoother curve. All right, if I want to put the vertex labeled there, I think that's really intelligent to do. I'm communicating with the reader. All right, so it was x squared minus 2x minus 10. So let me bring that up. And it was x squared minus 2x minus 10. Okay, and I'm going to zoom out. There we go. And look at that, negative 2 and 32 hundredths, and 4 and 32 hundredths, and 1, negative 11. And so there's my parabola. And this is how it should look. It's not how you really have to do with that airliner. All right, so let me go back to this first problem really quick here. And remember that our axis of symmetry was 0. Notice that symmetry is such a big, important thing. Our two zeros are two x-intercepts. We're at negative 2 and positive 2. What happens if you average them? You get 0, don't you? And you notice we got 0 for the x coordinates. Yeah. The negative b over 2 is just like averaging the two x-intercepts. Okay, on this one here, let's take the negative 2 and 32 hundredths plus 4 and 32 hundredths, add them together and divide by 2. We'll take the average, so I think that'll be 2 on the nose, divide by 2, it's going to be 1. Sure enough, there's the 1. All right, so that's a way to check ourselves really quick. All right, here's a third problem. A, B, C. Easiest, negative 1, 5, negative 2. All right, and so, tell you what, since I keep forgetting to do it first, I'm going to do the discriminant now. B squared minus 4AC. And so I'm going to take 5 squared minus 4 times negative 1 times negative 2. That's going to be 25 minus 8, which will be 17. So there's going to be two solutions. They're going to be irrational. So x equals negative of b plus or minus the square root of the discriminant all over 2a. Now, you notice that negative there. Watch what's going to happen. I hope you know, but check it out. You have 5 plus or minus square root of 17 over negative 2. Now, I'm going to do this work on a calculator. I'm not going to do it. I'm not going to figure out the square root of 17, get a decimal, and then round it. I'm going to round after I'm done. So, I don't have a calculator handy, like I said, but I'm going to go here, and I'm going to start a parenthesis, and I've got 5 plus the square root of 17, and I want to divide that by, what is it that I want to divide that by? I can't remember. Negative 2. Oops. So I'm going to divide by, maybe I better go parenthesis, negative 2. And let's see what happens. It's going to take that. It doesn't look like it likes all that notation. So here's what I'll do. I'll do the square root of 17. Uh-oh. There we go. Okay, so I get this big, long, ugly decimal. Now I'm just going to try to add 5 to it. Get that. And then I'm going to divide it by negative 2. And I always forget how to do these. You know what? I'll try that too. Negative. Nope, it doesn't like that. All right, I don't see a negative key, so I'm worried that it's not going to interpret right. Maybe I'll try this. -2. See if it likes that. Yeah, that looks right. Okay. Yeah. All right, that looks pretty good. All right, so it looks like we got about -4 and 5600. So I'm going to record that, -4 and 5600. So where's that graph? So the first x-intercept is at -4 and 5600, 0. And now I've got to do the same problem. Well, I've got to do 5 minus. So I'm going to get rid of that. And let's see, do I do it backwards? 17 and hit square root key? Nope, I don't. Sorry, I'm just not as familiar with this one. This is just Google, by the way. All right, so the square root of 17. Okay, equals that. Now I'm going to add. No. Sorry. I want to go 5 minus the square root of 17. Okay, and then I want to divide by -2. And there we go. We get negative 44 hundredths roughly. Okay, negative 44 hundredths. So we're going to get negative 44 hundredths as the other 0. Right? Yeah, I don't think I've made a mistake. Okay, so the two zeros are going to, that one's going to be right about 1/2. And that one's going to be right about 4 1/2. Right there. Now I got to go find the x-coordinate of the vertex. And so I just take the negative of b and I put it over to a. And I've got a mistake here because that's going to come out to be a positive. 5 minus the square root of 17 divided by -2. Okay, hold on a second. That's going to come out to be a positive. I know I've made an error because I wonder if that one's positive. No, I don't think it can be. All right, let me check my math here. I got -1, a 5, and a -2. I like that. B squared is going to be 5 squared, 25, minus 4 times 1 times 2, which is 8. That's -8, 17. All right, 5 plus, oh, there it is. Yep, I'm not doing the negative of 5. Yeah. Sean, why didn't you tell me? Come on, man. Let me down over here. All right, that's going to change these zeros. It'd be kind of cool how they change. I'm just going to erase them, but we'll do them again real quick now that I caught my silly mistake. And I'll bet they're both going to end up on the positive side based on where my axis of symmetry is. But let's go -5. So I need to bring this back up and clear that and go -5 plus square root of 17. And then I'm going to divide that by -2. And I get 44 hundredths, the positive version of it, didn't I? Yeah, there we go. That looks a lot better. Okay, so I'm going to get 44 hundredths, which is going to be right there. And I'll bet the other one's going to be like 4 and 56 hundredths. But better just make sure. Better not just assume. So I'm going to get, clear that, and I'll get -5 minus square root of 17. And then I'll divide by -2. And there we go, 4 and 56 hundredths. Very good. Okay, feeling a lot better about that. Sorry about making the mistake, but it happens. 4 and 56 hundredths. Okay, so right about there. All right, so now my axis of symmetry is going to be that line x equals 2.5. So that's going to be right along there. Sorry for the silence. Okay, now let's go find the y-coordinate of the vertex and see what's going to happen if you haven't figured it out yet. So, to find the y-coordinate of the vertex, I take the x-coordinate of the vertex, the 2.5, and I substitute it in for x into the original quadratic equation. And so, I'm going to get y equals the negative of 2.5 squared plus 5 times 2.5 minus 2. Well, 25 squared is 625. It's going to be a negative. That's going to be 125. It's going to be 12.5, positive, right? And minus 2. All right, so if I combine these two here, I'm going to get a positive 6.25. Minus 2 will be 4.25. And you notice that the vertex is above the x-axis. 4.25 be right about there. Yeah, so that's what, at 2.5 and then 4.25. And that happened because a was negative, right? All right, something like that. Now, just to show I haven't made any mistakes, let's go to the graph over here on Desmos. And that's going to be what? Negative x squared, negative x, oops. Actually, notice x times x is x squared. Did you notice that? It gave me a parabola because xx would be x times x, which is x squared. Yeah, it's pretty cool sight. X squared, and I think I said a plus 5x, then minus 2. All right, and so look at that, 44 hundredths, 456 hundredths, and 2.5, 4.25, just like we said. Now, what would happen if we averaged 0.44 with 4.56? Let's find out. Okay, remember, this is just to double check our vertex, okay? So, we're going to have 456 hundredths plus 0.44. 0 carry the 1, 0 carry the 1. 5 on the nose, 5 divided by 2, 2.5. Sure enough, it matches, doesn't it? Okay, so here's a video quiz for you. Haven't had one in a little while. You've got this equation. Pardon me, I feel sneeze. Oh, excuse me. Feel sneeze coming on there. All right. You're going to find the x-intercepts, and you'll do that by using the quadratic formula. X equals negative of b plus or minus the square root b squared minus 4ac all over 2a. And then you'll calculate the vertex. How will you do that? Well, you'll use that part of the quadratic formula to find the x-coordinate of the vertex, and then don't forget to plug it in. You got to find the y-coordinate. And then finally graph the quadratic on graph paper. All right, that's your video for tonight. Mr. Lawrence signing off. Have a good night, everybody.